All right, welcome to the Explainer. Today, we are diving deep, pulling back the curtain on something that's totally fundamental to JavaScript, but honestly, it trips a lot of people up. I'm talking about prototypes. This is like the secret engine under the hood of the whole language. So yeah, let's just get right into it and see how this thing actually works. Okay, so let me ask you this. Have you ever wondered, really thought about, how in a massive web app, you could have, say, thousands of user objects, or buttons, or whatever, and they can all use the exact same function without having to copy it over and over and over again? Because if you did that, your computer's memory would be a total disaster. So how does JavaScript pull this off so elegantly? Well, the answer is one of these ideas in JavaScript that feels kind of like magic when you first see it. But it's not magic. It's just really, really clever engineering. And getting this is the key to writing code that's efficient, that can scale up, and that you can reuse everywhere. The answer is the prototype. Okay, so here's the core idea, the big takeaway. Instead of every single object getting its own copy of a function, which would be super wasteful, JavaScript objects have this link, a link back to a single shared blueprint object. And that blueprint, that's what we call the prototype. So anytime an object needs to use a method, it just follows that link to its blueprint and finds it there. It's simple, it's clean, and wow, is it efficient. All right, so to really, really get how prototypes work, we've got to hop in the time machine for a second. Let's go back to the days before we had the nice, clean class keyword we have now. We're going to look at how developers used to build these blueprints using something called a constructor function.
So what you're looking at here is a constructor function. We're calling it person. Now, I know it looks just like a regular old function, but its job is totally different. Its whole purpose is to be a template. You see, when you call this function using the new keyword, it just poof, it stamps out a brand new object, and then it sets the name and age properties on that object. You can think of it like a little factory for making person objects.
Okay, now this is the most important part. Pay attention here. Notice we did not put the greet function inside the person constructor. No. Instead, we're attaching it directly to this special object called person.prototype. And that one move, that's the whole game. This ensures that every single object we create from person will share this one single greet function. They're not getting their own copy. They're all pointing back to this one. This, right here, this is the blueprint in action. So that whole constructor function thing, it worked. It absolutely did. But let's be honest, it's a little clumsy, right? The parts are kind of separated. So in 2015, with ES6, JavaScript gave us the class syntax. Now this is super important. It does not change how prototypes work underneath. Not at all. It just gives us a way cleaner, more intuitive way to write the exact same thing.
And you can see the difference right away, can't you? Look at that. The old way, you have the constructor over here and the methods on the prototype defined somewhere else entirely. With the new class syntax, everything, the constructor, the methods, it's all bundled together in one nice, tidy, logical package. Again, under the hood, it's doing the exact same thing. But come on, this is just so much easier to read and make sense of.
And here's another huge win for the class syntax: inheritance. Creating a new blueprint based on an old one. It makes it so simple. All you do is use the extends keyword. So here, class student extends person. Boom, student now gets everything from person. Then we use this keyword, super, which is basically just a way to call the parent's constructor. So it runs the person constructor to set up the name and age, and then we can add our own student-specific stuff. It's clean, it's clear, and it's really powerful.
Okay, so we've seen the old way with constructor functions and the new shiny way with classes. But there's still a missing piece, right? How does a student object magically know how to use a method that was defined on the person class? This is where we really look under the hood. This is the big reveal of the engine that drives all of this. It's called the prototype chain.
Yeah, exactly. Let's get specific. Let's say we make a new student. We'll call him Bob. So Bob is a student object. But we can call the .greet method on him, even though that method was defined way back on the person blueprint. So how does JavaScript figure that out? How does it find the function? It's actually a pretty simple logical search.
Think of JavaScript as a detective. First, it looks right on the Bob object itself. Hey, Bob, you got a .greet method? Nope. Okay, no problem. JavaScript then follows that hidden link to Bob's blueprint, the student prototype. It asks again, hey, student prototype, you got .greet? Still nope? All right, one more try. It follows the next link up the chain, this time to person prototype. What about you, person prototype? You got a .greet method? And bam, found it. It executes the function right there. This series of links, this upward search, that is the famous prototype chain.
And you know what's cool? We can actually prove this chain exists using code. There's an operator called instance of. So if you ask, is our student an instance of student? The answer is true, obviously. But check this out. If you ask, is that same student an instance of person? The answer is also true, because it's part of the chain. And you can even go one step further. Is it an instance of object? Yep, true again, because everything in JavaScript eventually links back to the base object prototype. This is hard proof that the chain is real and that JavaScript knows all about it.
Okay, so enough theory. Theory is great, but let's make this super concrete. Let's put it all together with one last, really practical example. We're going to build a vehicle blueprint, and then from that, we'll build a more specific car blueprint that inherits from it. So first up, we have our base class, vehicle. Super generic. It's got a constructor to set the make and a simple move method. You know, something basically any vehicle can do.
And now we get more specific. We'll create a car class. And notice it extends vehicle. It calls super to run the parent setup, and then it adds its own stuff, like a model, and its own more specific method, drive, right? Because a car is a vehicle, but it also has its own special behaviors. And here's the payoff. We create a new car, my car. We can, of course, call mycar.drive because that method is right there on the car blueprint. But, and this is the cool part, we can also call mycar.move, and JavaScript will just walk right up the prototype chain to the vehicle blueprint, find it, and run it. It just works.
All right, so let's boil this all down. What are the absolute key takeaways here? Number one, pretty much every object in JavaScript has a secret link to a prototype, its blueprint. Number two, these links form the prototype chain, and that's what makes inheritance possible. Three, that modern class syntax, it's really just a friendlier face, syntactic sugar, as they say, for the same prototype system. And finally, the whole point of all this is efficiency. We share behaviors. We don't waste memory by duplicating them.
And that leaves us with one final interesting question to chew on. By making JavaScript's inheritance look so much like the classical inheritance you see in languages like Java or C++, did the class syntax make JavaScript better, more accessible and powerful? Or did it kind of hide the very thing that makes JavaScript's inheritance model so unique, so flexible, and in its own way so powerful? Something to think about. Thanks for joining me on The Explainer.